Good afternoon, dear colleagues. My name is Irene. I am a postgraduate student from Kalashnikov Visual State Technical University. And today I am glad to share with you the result of our investigation connected with this flying ad hoc network, simulation and experimental study of multi-source application layer ARQ for flying ad hoc network. Today, unmanned aerial vehicles are used to solve various tasks, from private video filming to monitoring tasks of especially important objects. At the same time, today, when solving various problems, only one unmanned aerial vehicle acts as a source node, which is not enough for rapid monitoring of vast ground areas. In the scientific sphere, FANET with several relay nodes and only one source node is considered. The use of several flying source nodes in the network can make it possible to divide the server territory into parts according to the routes of their movement and register and transmit data in multi-stream mode at the same time. However, this raises the problem of quality of service deterioration in network associated with the load at input buffer over destination node, as a result of which there will be deterioration in the video quality at the ground station. The aim of our investigation is to improve the quality of multi-streaming video data transmission in FANET by requesting lost fragments of application-level data based on retransmission from several flying source nodes. In our work, we have developed models for multi-streaming video data transmission in unmanned aerial vehicles network with several flying source nodes, have developed a method and algorithm for multi-streaming video data transmission with the restoration of lost fragments of application-level data, and develop a software and hardware package that allows to implement the proposed method and algorithm. We considered two scenarios shown in Figure 2, but with different models in NS3. So, we considered data transmission from several unmanned aerial vehicles to a ground station using the application class, and data transmission from several unmanned aerial vehicles to a ground station using the Poisson-Pareto burst process. In the first case, we estimate influence of the number of sources on packet delivery rate, the distance between the source nodes and a destination node increased. And we also changed channel weight for the Wi-Fi and standard, and we also changed modulation schemes and coding schemes. In this slide, you can see some results of multi-streaming process modeling. As follows from the graphs presented in Figures 3 and 4, with an increase in the channel width, the distance between source nodes and destination node decreases. Also, with an increase in the channel width, the probability of collision with our network increases. And the main idea of this report is that an increase in the number of flying source nodes negatively affects PDR values, which indicates a deterioration in the video quality at the ground station. Also, we assessed the influence of source node number increase on goodput. So, as it follows from table 1, with an increase in the number of source nodes from 1 to 5, the goodput increases from 0.8 to 1.5 megabit per second to 4, from 4 to 5 megabit per second for different values of the Hurst parameter in the considered scenario. Based on the result of modeling the process of transmitting video data from several flying source nodes to a ground station, we can conclude that an increase in sources causes an increase in goodput requirements and a decrease in PDR, while overloads appear at the input buffer of the destination node, which leads to degradation of video quality. The solution to this problem is multi-source application layer ARQ method and algorithm. One of the basic principles of the algorithm is to determine the loss chunk from one of the source nodes based on the sequence number with identifier of the IP address. After identifying the lost piece of data, an ARQ is sent to the buffer of the source node. And we develop two types of MS-LRQ for common input buffers as shown in picture 6 and with separate input buffers as illustrated in picture 7. I would like to explain. In figure 7, two source nodes send chunks of data to a destination node. When transmitting data through a communication channel, the first node loses the second piece of data and the second node loses the first piece. The ARQ for the first node comes in the form of a response to the third piece of data. At this time, the fourth chunk is being transmitted, and after that, the second chunk is resent from the first source node. Now comes to the second source node after the second piece of data. At this time, the third piece is sent, and after that, the first piece of data is resent from the second source node. All chunks are sent to the buffer, after which, in accordance with the port number and IP address, they are broadcasted to the VLC application. In the first experiment, Raspberry Pi 3 Model B microcomputers were chosen at the source nodes. The choice is related to the fact that these microcomputers are used in unmanned aerial vehicles. And as follows from the graphs presented in figure 8, the proposed algorithm completely restored the lost chunks of application-level data from the two source nodes. In an experimental study of the efficiency of algorithm with a common input buffer, Clover small education unmanned aerial vehicles acted as source nodes, while a laptop acted as a destination node. The source nodes broadcasted the streaming video to the destination node at each control point, and the first control point was located at a distance of 5 meters. The 12th control point was located at a distance of 60 meters from the destination node. And the source node were removed from the destination node at a distance of 60 meters with step of 5 meters, as shown in figure 9. With two flying source nodes, the application of MS-LRQ algorithm provides an improvement in PDR with an increase in the distance from 50 to 60 meters by an average of 10%. With an increase in the number of sources nodes to 3, the use of algorithm provides an improvement in PDR with an increase in the distance from 35 to 60 meters by an average of 22%. In our investigation, we suggest to use multi-source application layer ARQ to improve PDR in multi-streaming scenarios. In the future, a promising line of inquiry is the development of prioritization algorithm for source node with the highest value of packet loss rate measured on the application layer too. Thank you for your time.